Greetings and welcome to the Introduction to C++ lecture. Now, before we get started, a quick correction on something that was said in the Visual Studio overview video. We are going to have to use multiple projects because of how C++ works. Now, for the following steps, do not follow along. I do not want you to mimic what I am about to do. I'm just simply demonstrating why there will always be two projects when you clone something from GitHub. There'll be the assignment project, and there will be a clearly labeled lecture project. So, and again, do not do these next steps. So in Python, we could have had two separate files. So for example, I would have the assignment file, in this case the main.cpp, and maybe a lecture demonstration file. And you might think, okay, it's like, yeah, well, simple enough. It's like, for C++, you have to have an int main. So, if I had that copied over into here, I could then do the lecture stuff in this file here, leaving the main.cpp for your assignment. Nope, the problem with that is if I try to run this, I'm going to get a build error. And I'm going to tell it no here because I do not want it to continue with the last build. And it's going to complain that I've already got main defined and I've got multiply defined symbols. The way C++ works is these source files are compiled into object files, and then those object files are linked together to form the executable. But that means that these object files cannot contain multiple definitions of the same thing. I cannot have main defined in both files. And you might think from there, it's like, okay, well, fine, this worked in Python. I could just simply change my function definition to something like, say, void demo. And make sure I put my parentheses in there correctly. Which is fine. There's no syntax error warnings here. But then if I come over here to main and I try and call the demo function, it's going to be mad at me. It says demo is undefined. It does not exist. Now, calling functions between files in C++ is not that simple. We will get to that, but you can't just have a file with a function in it and be able to call it directly like this. So the solution to this is in the solution file, there will always be two projects, a clearly labeled lecture project and your assignment project. And how it knows which one to run is quite simply which file do you have open. So if I have the main CPP file open for editing and I run, it runs that file. Notice there was no output. But if I have the file open that is in the lecture project, reviewlecture.cpp, and I run my code, that is the project that will be ran. So it is important to pay attention that when you go to do your assignment, you are not doing it in the lecture file. Any file associated with the lecture project will have the word lecture in its name. So when you're ready to do the assignment, close those files out, and you will be okay. It will automatically detect the correct solution to run, the correct project to run. In case you are curious as to how this is set up, if you right-click on the solution, and then you go to Properties, normally you have a single startup project defined, but I changed the setting to Current Selection. This will always be predefined for you. You do not need to worry about this. It will always be set up such that whichever file you currently have open, that is the project. That owning project is what's going to be compiled and ran when you hit F5 or you press the debug button right here. Okay, with that out of the way, let's talk C++ and the structure of a C++ program. C++ source files always end in either .cpp or .h for a header file. We will deal with header files later in the semester. There is no relation between a file name and the file contents. Doesn't matter if there's classes in here, structures, functions, whatever. There is no link between the name of the CPP file and its contents. When we get to classes, there are some very strong standards that you should follow, but they are not requirements. In a C++ file, if you need to comment something, as you can see from the included comments here, you use // This can also be put at the end of a line to include a comment like that. But there is no way to uncomment a line. As soon as you have those / marks, unless obviously it's contained inside of a string, it's going to be a comment. You can also do block comments by doing a /* and then a */. And anything in between will be a comment. Now the IDE will usually, when you do this, put these additional asterisks here just for a visual reference. These are not necessary. I can take those out and the block comment is still just fine. The important part for a block comment is that you have the /* and then the */ to close it. Something that you will see very commonly in a C++ program before any code is executed are include statements. Like most languages, C++ is just simply too large to include every single language feature at the same time. That would just be a gargantuan, inefficient mess. So we include different libraries and files to tell our program what functionality do we want. You will almost always, as in I can't think of a scenario where you wouldn't, have an include IOStream as one of your include statements. IOStream stands for Input Output Stream, and this is the library that handles all of the input and output to the console as well as file operations. So you will just about practically always have this when you are doing a console application, which is all that we will be doing for this course. Now there are two variations on the include, including libraries, which will usually have these angle brackets here, or including your own custom files, in which case you will usually use quotation marks. And we'll see an example of that once we start dealing with header files. Almost all lines of C++ need to end in a semicolon. There are some exceptions to this. Include statements do not have semicolons. Function definitions do not have a semicolon, not to be confused with function prototypes, which do have semicolons. Again, we will get to that. But a function definition does not have a semicolon, nor do the definition lines for if, else statements, for loops, and while loops. A C++ program will always have an int main somewhere as its entry point. This is mandatory. It will return an integer, and it will be called main. There are two variations of this you will see. For the most part, we are going to use this variation, the one that has no parameters in the parentheses. However, you will also see versions that look like this. int argc, comma, char star argv. This is for accepting command line parameters. We will eventually take a look at command line parameters, but for the moment we are going to stick with the version that just has an empty parentheses. Just be aware, if you see a main that looks like this, it's perfectly correct. It's just allowing for the possibility of command line arguments. All functions need to have an opening curly bracket and a closing curly bracket to indicate what belongs to that function. It is worth noting that in C++, white space is almost universally irrelevant. I can completely, legally, don't do this please, condense my entire program to a single line. This is completely valid syntax because C++ uses the curly brackets to define the start and end of the function and uses the semicolon to define the end of lines. So it has no problems parsing this to figure out what is going on. Again, don't ever actually do this because that is horrible, but it is legal syntax. On that note, indentation is not mandatory in C++. This is perfectly legal. This is perfectly legal. It stopped being helpful. IDE. This is perfectly legal. Again, don't do this to your code. Maintain discipline that you should have from Python to keep your indentation levels correct. I have a function, and so this is going to be indented one level. If I was to write an if statement, I would write all of the statements associated with that if statement indented in one level. Is it required? No, but it's a really good way of visually sorting your code to make it easier to read. If you come to your instructor for assistance and your indents are all messed up, one of the first things they will likely tell you to do is fix your indents and see if that shows you the problem. Because quite frequently it will. All right, let's take a look at this line here and its rather interesting format. STD, yes, get the giggles out of your system now. STD : cout, two less than symbols, a string, two less than symbols, and STD end L. You will also sometimes also see it like this. And in fact, if I am remembering how the code's going to be checked out, this is actually what you will be seeing right here. So what's going on with this STD stuff? Well, there's, again, as you are including in libraries, there are lots of variable names and lots of classes and lots of identifiers being imported in. It is not unreasonable to think that two libraries will want to use the same identifier for different purposes. To avoid that clash of identifiers, C++ has what are called namespaces. Everything that is in the IOStream library is under the std namespace. And so, since cout is part of the IOStream library, in order to use it, we have to type in std : cout every single time that we want to use it. Now, there is a way to get around this. You can, if you wish, after your includes, but before your code, put in the statement using namespace and then the namespace you want to use, which in this case is std. Now I can remove the std in front of cout and my program will work. Assuming I didn't accidentally delete a matching curly brace. There we go. It works. But if I remove the using namespace and try to run my program, well, already I've got red squiggles of doom telling me that cout is undefined because I need the std in front of it. Now, as far as your projects are concerned, if you want to use using namespace std to shorten the amount of typing that you have to do for things, I am okay with that. Generally speaking, I will not be using the namespaces because I want it to be very explicitly clear when I am using something that belongs to a namespace versus using something that does not belong to a namespace. So I will not be using namespaces for that purpose. Now, a quick note about this \n. \character is our escape codes. So in this particular case, this escape code is the new line escape code. It is more common in C++ when you need new lines to see it chained together with the endl predefined code. So when you're looking at a C++ line, this is more what you will see. Cout, whatever it is that you are putting out to that stream, and then an endl, assuming that you actually do want to end the line and kick it down. Variables. Variables in C++ are strictly defined. In other words, their types are defined when you create the variable. It's not a loosely typed language like Python. C++, like Java and C#, is a strongly typed language. So if I want an integer to be able to do stuff with, I have to explicitly state that a variable is an integer. You can define multiple variables at the same time by comma separating them. And you can even initialize a list of variables by separating commas and then putting in a z equals whatever value you want to initialize to at the end of it. You do have to initialize a variable before you use it. If I attempt to, say, use the variable a, without initializing it, when I run my program, I'm going to be told that there are build errors, and the build errors is uninitialized local variable a is used. Generally speaking, you should only create one variable per line. It is just a little bit cleaner to read this way and ensures that you don't have any typos resulting in accidentally not initializing a value. Variable naming rules follow the same rules as Python and Java. Alphanumeric, the first letter, the first character, I should say, of a variable name must be a letter or an underscore. You cannot have a number as the first character of a variable name. This applies to functions and class names as well. The scope of a variable is the nearest matching set of curly braces. So anything defined inside of main here will be visible everywhere inside of main. But say if I define a variable inside of an if statement, that variable will only be visible within that if statement. And if I had multiple functions, these two variables here would only be visible inside of main. Now you can declare variables outside of a function. This is a perfectly legitimate line of code. And if I attempt to output that value to the screen, it works just fine. The scope for this variable would be the file. From the point it's defined, and that actually is something that I glossed over. For C++, a symbol does not exist, and these will frequently be called symbols or identifiers. A symbol or an identifier does not exist until it is defined. So if I attempt to use the variable C up here, it will fail because C is not defined at this point. C++ is far more strict about this than Python is. If Python sees an undefined variable, it will just define it for you right then and there. That does not work for C++. You must define the variable before you use it, and that variable scope is the nearest matching set of curly braces, and if it's defined outside all curly braces, like this one is, then its scope is the entire file. This is what we call a global variable, and generally speaking is not a good idea. There are scenarios in which global variables are acceptable, but generally speaking, you should not have global variables. Everything should be defined either within functions or within a class. So let's take a look at some actual practical code here. Let's say that I wanted to get two values from the user and add them together and then display that result to the user. Well, to start off with, I'm going to want to define two variables. So I am going to say int val1 equals 0 and int val2 equals 0. Next up, I am going to prompt the user to enter something in. So I'm going to say std:\cout value1. Now notice I'm not putting in an end line or a new line character escape code here, because I don't want a new line. I want the cursor to stay on this line when the user enters in their number. But how do we get input? Well, std cin arrows in the opposite direction to the variable in question. Might seem a little fiddly at first, but you get used to it really quick. If the value is going out to the screen, the arrows point towards the cout. If the value is coming from the user and going into the variable, then the arrows point to the variable. They simply indicate the direction that the information is flowing. And if I run this real quick, we can see value 1, the cursor is still on the same line, and then I can enter in the number, hit enter, and program execution will continue. So I would put in std:\cout value2. Again, no new line code there. cin value2. And now I've got my two values. I need to do my calculation next. So I'm going to say int answer equals val1 plus val2. Now I need to display this information to the user. So I'm going to say stdcout. Now, there is no string formatter, at least not without jumping through some hoops. There's no basic string formatter like what you have with Python, where you can do the f and then directly embed the variables inside the string. We just kind of have to piece this together bit by bit. So I'm going to say val1 plus val2 equals answer. And this time I will put an inline. This will be the last line of the program anyways, but I still want to kick it down to the next line. So let's break this line down. So we have stdcout, stating that we're using the cout stream. We're going to send the contents of val1 to the stream. We are then going to send the literal string plus to the stream. Again, I'll try to enunciate my words clearly, but do keep in mind the difference between stream, the cout, and string, the literal strings of text. So then val2 will be sent to cout. Then we'll send the string equals. Then we'll send the variable answer. Then we'll send the string period. Then we'll send the endl, the end line character. And so that is how you composite together a line that integrates literal strings and variables to the output stream. And if we run this, value 1, I'll put in a 5. Value 2, I'll put in a 7. 5 plus 7 equals 12, which is the answer that I expect. Unlike Python, where all of your keyboard input is automatically considered a string, in C++, these stream operators, and this double caret sign here, both of these, both the one going to the cout and the one going from the cin to the variable, these are called operators. The stream operators will format their information based on what this variable is. So this is an integer, so the stream will automatically convert the data from the user. Oops, I'm sorry, looking at the wrong one. This one here. So when we're doing the cin, when we get that input from the user, val2 is an integer, so that stream data is automatically going to be cast to an integer. That does mean, of course, that if you put in something that is not an integer, it will cause the program to break horribly. Notice it doesn't crash. It just breaks and stops working correctly. This is one of the things that can make C++ a more difficult language to work with, because the way it fails is sometimes very counterintuitive. You would expect a crash here. Java would crash if you did this. Python would crash if you had a type mismatch like this. C++ is just like, oh, yeah, you just corrupted the input stream, so I'm going to do this crazy thing now. And it's not going to crash or even tell you that there's an error or something wrong. As far as this program is concerned, it exited with code 0, meaning there were no problems. So again, this is one of the things that can make C++ a more difficult language to work with. But you will also notice that the logic here is the same. If we think about in terms of how we would do this in Python, well, we do pretty much the same thing. We're going to display text to the user to greet them to the program. We wouldn't necessarily have to predefine our variables in Python, but it's always a good idea anyways. We're going to display text to the user to prompt them to give us a value. We're going to get that value from the user and store it in a variable. We're going to prompt, again, the user to give us a value. We're going to get that value and store it in a variable. We are going to do a calculation and store it in yet another variable. And then we're going to take the values of those variables plus some additional strings to put together an answer that we are going to display to the user. So the logic here is pretty much exactly the same. It's just the technicalities of how we go about doing this is just a little bit different. So again, as a quick recap of the format and parts of a C++ file, the file name and the file contents are completely independent of one another. There is no link between the two. If you need to write in a comment for a single line, you use // If you need a block comment, you can do a // and then a */, and everything in between will be considered a comment. Before you have any other code, you must have all of your include statements. You will almost always have an include IOStream statement because we are writing console applications and you need this to get input and output to and from the console. Optionally, after your include statements, but before your code, you can put in a using namespace std if you do not want to constantly be writing std : in front of your cout and cin statements. A C++ file will always have an int main as its entry point. There can either be no parameters for the main function, or it could have 2 parameters to allow for command line arguments. A function will always have an opening curly brace and a closing curly brace to indicate what code belongs to that function. All lines in C++, with some exceptions, must end in a semicolon. Function definitions, include statements, for loops, the definition of a for loop, while loop, and then the if else statements do not need semicolons. Variables are strongly typed. When you declare a variable, you must declare the data type. And a variable scope is the nearest matching set of curly braces. Variable naming rules are the same as Python's, alphanumeric, and the first character must either be a letter, capital or lowercase, or an underscore. And if you are not using namespace standard, anything that belongs to that namespace has to have std : affixed in front of it. So that includes cout, indel, and cin. Again, I will not be using namespaces, just simply so it is very clear whenever I am using something that belongs to the namespace. If you want to give output to the user, you use cout, with double less than signs indicating the different parts of the statement that you are sending out to the console. If you want a new line, you need to send std : end line or end L to the cout stream. If you want to get input from the user, that is cin, and the arrows need to point towards the variable where that input is going to be stored. So let's talk about the assignment. I am going to close the lecture file and take a look at main.cpp. And actually, let me get rid of this file, because that you will not see that file there. So when you have cloned this project, you will have the CPP review. And then under the source files for that project, you will have main.cpp. Your assignment files will always start with a main.cpp file, even after we expand into classes and other parts of the C++ language. So your assignment is to divide two numbers. You are going to prompt the user for two single precision floats. Make sure that they are single precision floats. Make it clear to the user which is the dividend and which is the divisor. Sanity check the divisor to make sure it is not 0. Then do the division and display the answer to the user. If the divisor is 0, then just simply do not do the division. Report an error to the user saying, I cannot do that. And then, of course, your code will go here, and you are free to include a using namespace std here if you so desire. You will need to do the reading assignments to have everything necessary for this. The reading assignments will cover up to if statements. And make sure that you read the section on data types so that you know how to correctly define variables for single precision floating point numbers. If you have any questions with the assignment, make sure you message your instructor on Blackboard. And with that, good luck with the assignment.